22 UK sono le dell'Italia, vero?
No.
Sure. Adesso. Yeah.
Ok, cominciamo. So, we are going to use net to make queries, AstroQuery, and net for make queries for this some objects. And in this way, we have used it. Have you tried this in net?
Yeah.
Then we can go to must. Let's use observation to must to query some objects. So from AstroQuery .must import observations. We have let's ask around some position, arc and deck. This is the radius to search around that position what is in the sky in the must database. Can you use must there? Must. Now you have to import from AstroQuery that must import observations.
I think it is the same problem with net.
Yeah, I don't know why. AstroQuery from AstroQuery must
From.
see that AstroQuery. That's right.
Must. Okay.
Observation.
Import. Okay.
Can you import me observation?
No,
Is it working?
just a moment. Yeah.
Can you
There's
import
a
observation?
There's a warning. Current string is being interpreted as a
Ci riuscite a importare observation?
Okay. Could you go here, please? Stop. I know it's empty, everything must, but I'm not. Could you please somebody import AstroQuery .must as with an alias? I make and show the dir.
Import.
Query must .must as with whatever. Okay, and dir must. Dir. Yeah, full of thing you have, but in your case it's empty. I
don't know why.
Oh, it's very. Okay, it's better. It's better. You are using 3.6. It's better. Okay. It's better. you have very the Fedora release 27 now. Fedora is by 30, so this is discontinued. You have to grade
Fedora 30. Okay.
30 because Fedora only make upgrades to 2 versions. So
Okay.
it's now upgrading only up to 28.
Okay.
So that's the problem. Okay.
Sebastian, suppose I would like to. So this is the jump stable. Oh, that was already done. This is the print.
Say just to bring the first 10
Yeah.
results.
No. I was. So suppose I would like, instead of printing the first 10, I would like to select the, let's say, the HST.
Okay, so
how do I do that?
yes. You can,
Odds collection.
yes, so you can say an equals, it will show you fails or true, because this is a list of fails.
So how do I do the
Columns, yes, plot columns there, columns, names.
This collection. That's
No, I think it should be call names, first print call names, to see what's in there. With no capital letters. No, call, that's right.
And without print.
Yeah, if you want print, you can print.
Okay,
So
it's
which is the name that you
odds
want?
collection.
Okay.
Which is absolutely.
Equals-
It's over there.
okay.
That's why.
So equals.
Yeah, it's
So now select that.
Oh.
No, that is a keyword.
so it's così.
Yeah.
Oh, that's
No, it's stringer.
yeah. Okay, so it's like this.
Okay.
Oh, that's equal H like HST.
Yes, that show you fails or true. Okay. Yeah. Say no. This is a list of okay. So first, remove print. Okay. Let me check. That's index. Okay. Raw.
Sì,
Okay.
arrivo.
True.
Vado sul
Okay. So now just show without equal to, just show the
Without this,
that one.
like this.
Yes.
Okay.
Okay, so now make values there or whatever values. You want the index. Value, or
It's not
what's the name? 0. Put 0 at the index. Okay. 1. Okay. So just now you have to equal that to the name of the equal. No 0. Just remove the index. Equal. Just to be sure that this is strict. Yeah. Just write strict.
like this.
Yes.
Okay, true.
So you can obtain now just
So let's
just move, just
say
say
equal something.
yes, right. And now just use that as a print. That's right. No people. Just the name of table and the index people.
Okay, quindi table and people.
No, of table. Name of the observation collection. Oh yes, yeah, sure. No, because there are several columns there. Now you have selected only row with, so you have to say what column.
How do I don't remember? So it says like this people.
No, this is at the end. First, the column that you want to plot. No, like this.
Oh yeah.
Ops collection, for example. And now people in there. Yeah. And close. Yeah.
Okay.
There you go. You have the only HST selected.
Okay. If I want to have everything,
Yes.
without ops collection. Okay, just say print people.
No, I don't think so.
Yeah,
It's
it
work.
works.
Work?
Now,
yeah,
if I want
okay.
to have also
Yeah,
the
people,
list,
just the column, at the column name.
yeah, okay.
Okay?
Yes. Vediamo, a te funziona da must. Questo è qui.
Okay, so we have this. So we can also use result name with query object.
Sì, ma mi ha dato
Radius.
un warning.
We can use the sky coordinates, or we can use, remember, we can use query region if we want a sky region like this, or query object if we want what is around an object and radius. Okay. So with query criteria, you can also limit the query, for example, by using HST criteria. So with query criteria, we can select what type of data proof. For example, if we want image, proportional PI, for example, and all the, for example, what is the declination of the object, and then it will show that. It's a selection.
I have a problem.
Also, we can use filters, in which filter has been observed.
I have an error with M8.
Which one? No,
Which is the query with the name of the
name.
Yeah.
Okay.
No, it's query. No, it's query.
No, query criteria.
Sorry, it's query object. Sorry.
Query object. Vediamo? Come va?
Sì, io ho un warning all'inizio.
Ma
no, anche
funziona?
Switch
sì,
RS.
è un warning, ma
poi
funziona.
mi dà
Sì,
questo?
sì, è bene, bene.
Ok, poi è fatto con,
Sì,
con la
bene.
Perfetto. Sì?
Sì, bene.
Adesso sto facendo l'ultimo. Uguale.
So we can also set it by filter. So query criteria have several keywords for the selection, okay?
I can also, for example, identify some instrument, specific instrument.
Yes, yes.
Exposure time.
Yeah, probably. I don't know. Just ask query criteria question mark. It will show you all the.
Yeah. Okay. Let's see what I want to see if this one works. What's wrong? Okay, so.
Ciao. Gaetano was
I think it's
queried by
somebody was.
asking for. Okay. So now, Anna, we are with the query, astro query must here.
How do I know what are the possible keys for query?
Ask question mark. Use the observation query, whatever, query region, whatever, question mark. Question. Observation, punti, punti, query, whatever you want, object, coordinates, or criteria, criteria, and question mark. Put a question mark, and show you all the keywords.
It doesn't seem that this is possible. Object region.
Okay, so there are a bunch of.
But there is no, I don't see any possibility.
Okay, let me check. It's a criteria. Okay, it's a criteria.
Yeah, that's it.
Yes, yes.
Yes.
Let me read it. So, okay.
Coordinates,
There-
radius.
At least one non-position criteria must be okay. Valid criteria are coordinates, object name, radius,
Yeah, there's no exposure time.
and all observation fields returned by get metadata.
Get metadata. Okay. And and get metadata is a
Yes, because different mission has different metadata.
mhm.
So, for example, to list the missions, we can have this. Let's say that okay, here, see,
Okay.
observation get metadata, observation. It will show you all the valid values. Okay, so observation list missions show all the missions. Okay, that we have. And we want to get the metadata for each mission, so for the query, we use observation, get metadata, and observations. And it will show a table with column name, column label, and valid names, okay? Filter, here, column label are the criteria.
Okay.
So metadata products shows what product are in mass, pseudo-load. Okay, so this query region, query for a sky coordinates, or object, query object for an object within a radius. Okay. By default, the radius I think is 0.02 degrees. Okay. If you don't give the radius, by default it clicks. Or you can make some criteria to filter out the observation with query criteria. You can say data product, just image,
Okay.
the
Why-
proposal
why-
PI,
Yes.
the coordinates range.
Okay. What is the use of meta table?
Yes, now, for example, these are different criteria. Okay,
Okay.
you can use also with filter, project name, or
Okay.
okay. So okay, we can have the number the how many observation has been done for an object with query object count. Okay, like this. Of with some filtering with query criteria count.
Okay.
Because each product have different criteria. Could have filters, could have Tmax is the observing maximum time. We can see what criteria can we use with observation get metadata, and here it will show the different criteria for each
Okay.
column. Okay, for filters, for example, these are the criteria. For example, column name are the criteria, and for the criteria we have different valid names. Okay, so we can use this name with this criteria to filter out the queries. Okay.
Okay.
So I don't see. Can you help me to find if there is a disclosure time, for example? Disclosure time, for example, it says the field. So in the metadata of observations, you can get the filter, the wavebands.
Yes, this is
the mission.
this is the query.
Yeah, but there is no other. Oh, so
No, because you are limiting so there are more. There are more than this. See this point, that is the beginning. and this is the
But
end.
how can I search if there is also the exposure time?
It is equal. Remember, say equal
No.
X time. or just put this in a list because you are printing. If you want to show everything,
Yeah.
just put this in a list.
Uguale questo?
Yeah.
This.
No, columns. You want to show column names, okay? Just print column name, column name.
Yeah?
Yeah. Column names.
Yeah.
Okay. What is in AA? Oh, these are the column names. And now for column name, just all the keyword remove column names and put remove the punti and the keyword column name.
Like this.
No, like this, exactly like this.
Ah,
And it's keyword, so it's in parentheses.
in square parentheses.
Square. Okay. So we have,
How do I show you the full list?
the full. So you can make a loop for A in A in A, punto punti, print A.
That's
A,
it.
yeah.
Oh, TX time.
Ah, I think it's right there. I think in the example. Let me check.
Okay.
Yeah, no, it's
So-
T-Max.
So I'll need to understand, just to put in policy, suppose I would like to search in the master archive if there are HST observations of M87 with exposure time larger than,
yeah.
and with given instrumental filter, let's say
Yes.
814W.
So you
I can do
use
that.
you need filters
Yeah.
here and TX time larger than and the value.
Okay. Okay.
That's it.
That's-
Okay? So let's say that we have we have an ID, observing ID, so we can use get product ID. Let's say that we have this for the observation. Just we can get all the observation for that ID with get product list and the observation ID. Okay. So let's download some data for that ID, or just so let's define this ID and see what is in this observation proposal. And we can download the data product with download products and the object that we have created with product list, get product list.
Just downloading a lot of stuff.
Yeah. You print manifest, you will see what is downloaded. So it will, now will download two. One is a GC file and a FIT file. And in the manifest, show you the information that you are downloading. Okay.
Okay. I have to wait for the new version of Fedora.
Probably we have a problem with the zip file.
say not to flush. Okay. Okay, show me again what have you done? No. Okay, manifest. And can you show me first what is data product, print data products? Okay. Okay, is there? Sorry. So now you can download products.
Se basta che non
Oh.
sposto.
So, so
No, manifest observation.
okay, so now manifest data products, okay, yeah. So should download.
No,
That's
because-
very.
Quali sono e dove sono?
No,
You are connected, right?
yeah, but it seems that the download
It has some problem.
Yeah,
So,
probably.
do you see if it has been downloaded? See LS. Make a list of the to see if you have the stuff downloaded. LS there. Enter. Yes, I think it creates some file. Where is downloaded the data?
It generates
A directory.
directory.
A directory that is called
Must download.
must download. Look for that. See.
Must download.
Okay. See what you have inside. LS and the name must. Minuscule and must. Could you change to must? Just change to the directory. Okay, there. Okay. So we have now downloaded the data. Okay.
Provi a arrivare a tele vuota.
La cartella è vuota? Ma no, dentro ci sta una IOI, dentro ci sta un LWV così via, e dentro ci stanno i file
È
GZ.
dentro vuota.
A te non spiega, non sono GZ.
No, problemi sociali o non importa di Z.
So this directly download the data, but we can create a curve file just to download later. Okay. Then instead to download them, just to say, just showing the curve flag true.
And then
It create a curve file. So after that we can execute the file. Actually, is a fichel or bash file that contain a curve code. So after that we can call the. You see this. The name is must download and the name of the product. I think it's a random number. So it's a bash script which contains a curve call to download the data later.
So the ops ID is something public?
Yes. It's in the master catalog.
Yeah.
So you can. So also we can specify query for downloading. Those subgroup description, we can say, okay, we want image, raw, uncalibrated, so we can use those keywords, and we will do, and the extension, we can specify extension fits, and it will download that only that criteria products. Okay. Any question about this? Let's have a look.
In
Yes.
the download the product, the first keyword is the ID.
Here, okay. The first product is is the ID. If you say okay. So you can say, oops,
Yes, okay.
here get product. This is
Yes.
this construct product list. It contains data products with this. This is an object that has the information about this ID, observing ID.
Yes, no,
And then with the log product, just you need the product, not the ID. Okay.
Yeah, no. I
This
understand
is-
this exactly.
This is a product that is not the observing ID.
not the-
It's
okay.
a product that is obtained like this. Okay. This is not the observing ID. Okay, it's the data product that could be a different number. To go from observing ID to data product, we use get product list with this.
Okay.
Okay. Okay, so let's work with fixed images now. So we will need EO from Astropy to work with fits. Let's read some fits that we have in the course. So from Astropy EO import fits, and we use fits open and the name of our fit files. So now we have an object that now here I have called due list, and due list info show the information about that fits file. So you know a fits file contains header, which is a text file, and the data that is an array of the size of the CCD, the detector, with the information that we need. If it is a cube, it will be contain a 3D array of the dimension, and for each observation, a third dimension. So the header, how can we obtain the header? The header is the index 0 of the object that we have created, header. So this would read the header. So we can list the keys of the header with header keys, it's a dictionary. And we can access any value of the header with the keyword as in a dictionary, object, or position, sky, coordinates. Is it working?
Yes.
Good, good. So what if we want to modify a header, change the values of header? It's very simple, just the name equal what is the new value. So let's say change creator and put your name there. To change the keyword creator and see that it is and check that already has been modified. So change the header, the value creator in the header and put your name there.
Stupid question, Sebastian. Why when dealing with the fits file, it's always used as HDU? What's the reason for that?
To use what?
Why I see here?
Oh, you can use any
Why-
name.
I know, but why HDU? Is there? That,
Header, yeah.
ma non è solo per la header, anche per i file. Also for the bits file.
It's usual to call that. You mean?
Yeah. So I know it's a convention, but
Yeah,
you can also
convention,
call
but-
it people. But why
Yeah.
always HDU? I don't know.
I should. Yeah.
Ogni volta che apri un file, c'è sempre questa HDU.
Yeah, I think so.
Ma non è un'idea, anche quando non apri il whatever.
Okay, so what if we want to create a new keyword in the header? So we use header insert. Dot insert. So here the first argument is where to place the header. And you know, header can be placed in any place, but we are saying here, okay, place after true creator, okay? And now a tuple with the new keyword, which is the new key owner and the value of the new key and the comment. It's a tuple of 3 elements. The key header, the value of the key header, and the comment about the key header, the new one. So we need where to place, around which actually keyword, and if we can place before or after. With after, by default, this places after. Okay. If you don't give after or true or before true, it's placed after. So create this new keyword and see and check that has been already created.
So do.
Okay.
Ok. Come questo funziona?
Creators is included, okay? And the owner is included?
Yes.
Okay, perfect. So we know how to modify the header and access the header, right? Abbiamo tutti accessi? Okay. So now let's access to the data. With, it's very easy. HDU list data. Instead of header, the same but data. Okay? If we ask what type of data is an array, multi-array. Okay? And what is the shape? So it's the shape of the detector. So each column and row have information about the counts. Okay? So okay, before let's plot the data. You know how to do it. Okay, thanks. Now plot the data in log scale. That's the data. Now plot the data.
Ah, ok.
Plot the data. It's very simple.
PL.plot.
It's an image. Well, we'll
in show.
That's right, in show.
PL.show.
That's right. Just instead of plotting the counts, plot the logarithm of the counts.
You
You
can
can
use
use-
PL plot, but it's simply another plot of all lines, right?
Yes,
I did it.
yes, just overplot. In show overplot. I mean, so you don't see the former one. I think it's erase the image by default. It's not like a plot that by default doesn't remove the previous one. Because the alpha is equal to 1 in show, so it's overplotting everything. So plot the image and plot the image, the logarithm of the data. So you will see more different in the, okay? MP is,
Yes, this is
NP?
np.log.
How do
no,
No,
have you
no.
imported, no? Did you import an NP?
Yes.
So it's
No,
not,
No,
but
it's
later.
just
no, because it's
so
not
I
defined.
do the logarithm.
Okay, this is.
It's not that there is a
in
an
this
argument.
No.
I thought there is an argument to plot. Okay. I see.
So,
This way.
yes, that's exponential logarithm.
Okay.
But yes, you can see a little bit more. Also, you can use that within show with CMAP. There is a logarithm map in the color, so you can plot the data and the range of color be a logarithm, or you can plot directly the logarithm. Okay?
No, what?
PL, how did you import? No, it's PL in show, but you are writing ML.
Ah,
Okay? Okay? Yes. Naturale or decimal. You can plot directly without calculating. Also.
Can I change the cuts of the
The what?
the cuts of the plot? Like, I don't know.
The caps, which this.
No. This was, I don't know, like something like this, you know, to
Minimum and maximum. So, yeah, P-color with P-color. You will need not win show. You remember we saw P-color, PC color from. It's a way to show a 2D image. We saw that. So surface image,
yeah.
PC color,
Yeah.
P-color, and UV-min and UV-max. So you can limit. So you can try P-color, for example. PC color. It's P-color and the array.
I need to open
PL, P-color.
We don't need
Color.
to import.
No, because it's from P-color is.
But it's doing now, and it's probably something wrong.
What?
I don't know, it's doing nothing.
No, taking some time.
Okay.
Maybe.
Okay.
Take some time.
Mm.
Yeah, because it's let's decide.
Okay.
Okay.
No, right now,
Wait.
do you have 2000?
Yeah, you can see P-color, max, min and max. Ok?
Voi l'ho fatto più ora.
Ci sto pensando.
Sta pensando?
Just thinking about that.
But P-color the difference between
show.
and show is that it takes directly the value and plot there, and we piccolo interpolates something. Okay,
okay.
so that's because and it's the same for what's the other surf color. Surf is even is not faster because this is a faster interpolation. Okay, you can stop it. It's very.
It's Control C.
Yeah, Control C. Stop.
Yeah, okay.
Fermo, rimando di lavoro.
Okay.
Oh, io ho abbandonato.
No, io ci sto facendo, però adesso pure per portarlo. Per l'immagine. Ecco, fatto.
So
Oh, coperto.
It doesn't change much.
Non vedi il rimasto, eh?
Yes, sì, but
So how to, if we want to write the chains, we can use our object, write to, the name, and that's it. Or if we want to, okay, if we want to overwrite our fits file, for example, we have to open with mob update, okay? Once this is open, we make the chain, and to save the chain, we make flash and close. And then this will save the chain to our file. So this is overwrite, and this is create a new one. Here said overwrite true, but actually it's not overwriting the previous one. What it said that if this exists, overwrite, but because if we give a new name, that's not a problem. Okay? So what about tables? Fits tables. Okay, we have a table there, which is current 3 photons fits. Let's open. It also open with fits open, it's the same, but automatically identify if it is a table or a fits file. So HDU list info show what is here. So we will see that we have bin table here in the second index and the dimension of the table. Okay, and what is the format? To access to the data, we say use our object data because one contains the data. Okay, here you can see we are using index 1 because info show that the table is in index 1. So we can access the column names of the table as we have seen in Astropy with columns. Columns info show information about the columns. Actually the format and all these things. We want to access any column, tablet field, the name of the field, okay? So we are accessing the first 5 data with the that contain this field. Okay. What if we want to add a new column? So let's create a new object that is a sum of the position in the sky coordinates. So we create a new object. So we, by adding together the information of right ascension and declination, accessing to both fields like this. So we create new data. Once we have this is only to create the data, and now we create a new column with fits column. We set up the new name, what is the format, and what is the data with array equal to the data that we have created. Okay. And now that we have the new column, we add to the fits file with fits called defs in this way. Okay. This is definition fit call depth. Add to the table column that we have already read, the new column. And then we add to the bin table with this. And we write in this way. Okay, so this is how to work with tables in fits file. Very quick. We want to quick read the header and the data for a fits file is a command instead of opening and then as reading with header and data. We can use directly fits get header. So we will obtain the header of this fits file, or fits get data and we obtain the data. That's very fast. Okay? Or both at the same time with separated. That data and header with fits get data and with header equal true. So it will read data and header at the same time with get data. So if we want to get a value of the keyword without opening and accessing the data, just with get val, name of the fits file and the keyword will be obtained the keyword with get val. Okay, get val, get the value of this keyword in this fits file. Okay, funziona? Okay, so let's go to our last point in Astropy, which is the work coordinate system to make to access to the coordinates work coordinate to get position, the cut position using the pixels of the image. So let's use again our fits file, but now we need work coordinate system from Astropy. Okay, so from Astropy, that work WCS, import WCS in capital letters. First, we have to open our fits file with work coordinate system. So this is directly goes to this fits file and read the keywords that are necessary to make the transformation. Usually the rotation with the distortion of the thing and the reference pixel and the sky coordinate of that pixel. Okay, so now we can convert from pixel to sky coordinates and the opposite, from sky coordinates to pixel. So convert to pixel position, let's say that we want to know what is this pixel position in the sky coordinates to make astrometry. So we will use W. We have created the object first, reading our fits file with WCS. We all means make all the correction. Okay, distortion, all the things. So take the full matrix and make the correction. All picks to word, and we give the this is 0. Always I have to read about this, but we give the two x and y, and this is 0. I don't know. Let me check what is the last one. Okay, yes, okay. The last argument is in case we have a cube. So this say use the first. If we have only is the first one, okay? So it is the axis of the cube. Okay? So this will show you latitude and longitude. So we can compare to sky coordinates with sky core in different format. Those are actually sky coordinates, degrees. Okay. So now we can do the opposite. Let's convert this sky coordinates to pixel with word to pix, all word to pix, and we give the.
Give me an arrow.
Okay.
Give me an arrow.
What's error? Okay.
Index error, double index, double tuple. Index out of range.
Have you give 0 at the end?
Oh no. Oh yeah.
Okay.
Sebastian, let me ask you
Okay.
something. So suppose now a different problem, but it always deals with the WCS. So I have remember what I was doing yesterday, I was generating some coordinates, let's say. And the coordinates are on sky. And I want to project them in X and Y. Can I use this?
Yes, what you have to give is your object now, W, contain the transformation matrix. So you have, you want to give a specific transformation matrix, you have to modify this one. Okay. See? So,
Yes, but then, so in my word coordinate system,
what is, yes, you have to say,
I have to generate a file where
you have a fixed image, or you want to create, you want to generate,
so I
you
have
have pixel and you want to convert to sky coordinates.
it's all the way around. I have sky coordinates,
Okay,
like,
and you want to convert to pixel.
I don't know why this is yeah, and I can convert that to pixel.
You need this information to convert to pixel, because that depends on the camera, the distortion, what is the size of the pixel, and what is the pixel reference. So you will need something like this to create down objects with something like this.
So I have to generate
Yes.
to
yes.
save my table of data with Ryan Deck.
Mhm.
It's not an image, it's a table, and I have to save the table with an header including those
Yeah,
numbers.
I mean, you have sky coordinate, want to convert to pixel, it's like you are simulating observation, right? So you need to say what is this observation.
Sorry, question. When we use to convert pixel position to WCS, and we use the 30 and 40 for the position. When we convert the same sky position, because we use the same longitude and latitude to convert to the pixel.
No, not exactly the same. It's different. It's rounded. I obtain 148.
Okay, but in this case, the pixel are
No, it's not.
1,584.
Yes, but could be because now it's is degree. This is degree.
Sì, è quasi mezzo grado.
Now degree. So that's the difference is 0.3 degree. That's all.
Degree. Okay. Yeah.
Okay.
Okay. I understand.
If you use exactly this, you will obtain this. Okay. Any question about this? Should we make some exercise here? Okay, let's do this. So let's use determine the sky coordinates of M81 with the catalogs. Okay. Now read the file that we have there, and now obtain the sum of the counts of M81 within one arcmin of the center. Do we have the coordinates? I mean 81.
How do I access the X and Y?
X and Y of the image.
Yeah, for the
Data is a row, are the Y, and the column are the X.
okay. Yeah, but do we access in pixel units, or I mean I think it's in
They're the
coordinate.
It's called pixel unit.
It's
No,
called,
pixel unit.
but we don't know the pixel scale. I mean, we don't really know. I mean,
Work,
we can,
work coordinates transformation. You know,
but we can directly work in sky coordinates. Could we? Because
if you make the transformation, you need to make the transformation. For example, you can transform the full range of coordinates. Okay, you can give between 0 and 2,400. You know, a mesh grid, and give that to work coordinate system and transform that, or just work in pixels. So for the best way for sky coordinates is sky cord from name, right? Directly. M81, and you will obtain the sky coordinates. That usually is the center, right? So now with that, you can obtain what is the center of the in pixel of the image with transforming that.
You mean where the position of that coordinate is in the image?
That's right, in pixels. So that coordinates are sky coordinates, so you can transform to pixel coordinates using the work coordinate system and read it from the image.
Però io ho provato in questo modo, solo che allora questi sono i gradi, però non riesco a...
Oh, because it's, you know, punti means that you can access the ra and no, print ra with this is the keyword ra and deck in stringer. Yeah, close stringer. No, ra. Ra, no, it's capital. Okay, enter. No. All one by one. Ra, enter. Okay, here you go. And deck.
We don't know the pixel scale now, right?
Is header or something that is inside this information. That's probably, this is the matrix transformation is there. Okay. Yes, this is the pixel value. Okay, this is the pixel value and the coordinate scale, sky coordinates. So this is the pixel reference and the corresponding sky coordinates, and the pixel scale is in here. This information. This is the rotation and the scale. So this is the pixel scale, but you don't need it.
How do I pass them from arc-minutes to physical scale?
With work coordinate system.
Okay. Those are it. No.
Here we go. So, if you want to transform to work directly with the sky coordinate instead of pixel, as I said, you create a mesh grid like this. So X, this is the size,
Yes.
and Y, the same, X and Y, and mesh grid. So this create 2000 by 2000.
Yeah.
All right, and then you just give X and Y,
Okay.
and you will have in that long that thing. Okay, long that. Okay, because it's 0 and 1. Yeah. Here we go. Okay, that's it. So you can work directly with that. So these are the coordinates for longitude, and this is for latitude. So you can now make a search in radius. What is the center of the
in coordinates or in pixels?
in
Coordinates.
degrees?
Degrees. Let me see.
148 point.
148 point something.
88.
88,
88, and the other?
And 69.065.
Should it be 1 over 60?
Yeah, okay. So just for example, selecting the coordinates, I'm using this. But you can do this. For example, I'm selecting all that is less than a radius, which would be that the difference between the all the coordinates and the center is less than something. And let's say that now I want to add also the other coordinate. And here, okay, put the same but for the other coordinate.
But that's a square, right?
Yeah, so you should add, for example, you can first create a radius,
Yeah.
and then look all the values. Let's say we can create a radius like this, r equal this is distance to the center minus 1, I think is 148.88 to the square. Okay, plus, oh, this is 0, I think. This is the first component, and the second component 1 minus 69 whatever, right? From something
06. Okay.
square, and this is the square root. There we go. We have the values. So now it's very easy just to say less or equal that it's 60. What is something like that? Okay.
It's 0.016.
0.00617.
17. Yeah.
0.017. Okay. How many? Those are the number of pixels that we have. Okay, there. So now with data, if we have data LL, so there we show. I haven't data here. I think it's better. It's yeah. So LL, if shape is the same size of the detector, so we can now use LL with the data by reading actually the list. That one, okay. Oh, get data. Directly. Get the data. There we go. List for. Oh, because it's the data. Shape. Yeah. So we can use this There we go. Zoom list. That's the zoom.
Can you go back?
Yeah.
Okay, first, recapitulate.
Yeah.
So we have a detector,
Yeah.
2000 by 3000, okay? Which is we have already read this, which is in pixel. It's an array, okay, of that dimension. We don't care about the dimension, what is the coordinates, because now we are using these coordinates, okay? So with this object, we are going to transform this array with the information given by W to coordinates. So, because we are imposing not a radius of pixel, but in sky coordinates, arc minutes, we cannot work directly with an array, okay? We have to transform the position in the rows and columns to sky coordinates in degrees, let's say, okay? So for doing that, here we can give pixel by pixel, or just an array containing all the pixels that we want to transform. That would say an array of between 0 and 2000, 0 and 2000.
Well,
A square root, a matrix. Okay, we can give here numbers, 1 pixel by 1 pixel, and make all the combination 2000 by 2000, or just using mesh grid, and give directly the array, the 2 by 2. Okay? Okay, so we can use, yeah, this is exactly the same. Look at this. Okay, I'm going to create, okay, the new core. I will do, I can do this, okay? I'm creating an empty array, here, empty list, and now I'm doing this. For, let's say, X in NP arrange 2048, okay? For E in NP arrange 2048, okay? So I'm taking all the pairs, okay?
Yeah.
So new core append W all pix war pix to war X Y 0. That's it. But see how long it takes?
It is the same. It's doing the same thing.
Exactly the same that I'm going to show you now. Because it's taking pair by pair and I'm doing conversion one by one. Or, let's stop this.
Yeah.
Okay, or let's create an array by the 2D between 2001 and each array contains the position, the pixel index. Okay, so X, this is X. Okay, so arrange. So this is goes from 0 to 2047. The same for Y. Okay, but this is shape is 2000. So we need a 2D. X. This is because we have mesh grid. And P mesh grid X Y. Now X. See how fast is to convert this shape. And the same for Y. So just directly long lat equal pix to war X Y 0. See how fast, instead of giving one by one, take everything and do it. So long, or the longitude, and lat, or the latitude. So now we can work directly with long and lat. Okay? So let's create our criteria of the radius, which is this, for longitude. Okay, now this is capital line, this is long, this is lat now. Okay, so very fast, our shape has the radius of that. So now let's search how many of them has less than 1 arc per minute. Okay, the value is now it's that data. Actually, this is there we go. That is our galaxy without any limitation. Oh, yes, yes. Yeah, because this, if I'm using this, I have to multiply this by this, because if I'm using this, that is taking only a one-dimensional array. Okay? So that's, there we go. That's the what we have selected. Okay. Probably it's not the center because I have put some different numbers there. Okay. Any question? Quite powerful.
No.
Once you start to think
Adesso
in
chiaro.
Python way, everything is more easy. Okay, so let's stop here. So we have two lessons to ahead and to finish. So the next one is the last one is dedicated to the machine learning algorithms and multivariate fitting. And the next one, which is? Oh, you should have not correct. What is the
Pandas, maybe.
Panda? Sorry, Panda. So yeah, Panda is very powerful for handling data, interpolation, all the things. So if you have any request, one is the Fourier analysis.
Yeah.
So we can just send me an email that is not in Panda or in the machine learning, and I can rearrange, for example, to include in the next class. Next class will be Monday or Tuesday?
Tuesday.
Tuesday, okay. Tuesday and Friday, okay?
Friday?
Friday?
Yeah, should be.
Okay,
Tuesday.
okay. So I can put in either of them.
Which one of us is expected to stay in... Chi lavora nel lavoro agile? Chi sta nel lavoro agile? Parte Adriano?